Another component of 6.2 Day 2 involves fundamental trigonometric identities. These identities will help you in simplifying expressions and solving equations. We have reciprocal identities, which should be familiar to you, and then we have quotient identities and Pythagorean identities. Notice the 6 reciprocal definitions for identities. Sine is equal to 1 over cosecant, cosine is equal to 1 over secant, and tangent is equal to 1 over cotangent. And we can reverse those as well. Cosecant is equal to 1 over sine, secant is equal to 1 over cosine, cotangent is equal to 1 over tangent. These reciprocal identities are the same that we talked about earlier in Lesson 6.2. And then we have some other comparisons that will be useful throughout our semester. Tangent can also equal the quotient of sine divided by cosine. Cotangent is equal to cosine divided by sine. So those are just other kind of ways we could utilize those two definitions. Pythagorean identities kind of run off from the fact that a squared plus b squared equals c squared. But now we're going to utilize some trig definitions to help us with that. The most common one you'll see is that first one with sine and cosine. The sine squared quantity plus cosine squared quantity will always equal 1. And that's related to the circle that we've had on some of our examples that we've drawn angles on. We'll use more of that 1 later in this chapter. Another version of Pythagorean identities, 1 plus tangent squared equals secant squared. And then yet one more, 1 plus cotangent squared will equal cosecant squared. These identities, reciprocal, quotient, and Pythagorean, will be used throughout the rest of the semester. It's important to note that these identities are useful when simplifying expressions or solving equations. In some instances, you'll be able to move terms around in an identity, like sine squared plus cosine squared equals 1. Well, if we had 1 minus cosine squared, 1 minus sine squared, that would equal cosine squared. Or secant squared minus tangent squared would equal 1. So there are some things that we can do in that regard. However, some things we can't do. Notice sine squared plus cosine squared equals 1 is true, but plain sine plus cosine is not true. It's not a legal step to take the square root of an addition problem. So just be careful on that. However, you can square a fraction. 1 over cosine squared would be the same as 1 over cosine quantity squared. And 1 over cosine is equal to secant. So this would be equivalent to secant squared theta. So that means 1 over cosine squared theta is equal to secant squared theta. Now remember, some terms can have multiple definitions, which means you could use more than one solution, just kind of depending on the situation. Tangent is equal to 1 over cotangent as a reciprocal, but as a quotient identity, it's also equal to sine theta over cosine theta. So you have those two choices. You'll just have to decide which one is most meaningful in the problem that you're simplifying or transforming. Let's start with simplifying. When you simplify, your goal is to try to reduce whatever you have down to one final term. It could be a number, it could be a trig term, it could even be a squared trig term. But we want to try to get rid of anything being added, subtracted, or multiplied. These examples down below, it says simplify each of the following. The first one is already a product. We have 1 plus cosine angle A times 1 minus cosine angle A. In this section, we can't say that 1 plus cosine A equals sine A because we can't take the square root of that Pythagorean identity. What we can do to eliminate the parentheses, however, is FOIL. So we're going to FOIL on this one. Foiling will do 1 times 1, that would be the first. 1 times negative cosine would be minus cosine A, that would be the outside. Cosine A times 1 would just be positive cosine A, that's the inside. and then positive cosine A times negative cosine A. Cosine times cosine would be cosine squared. So we square the trig term, but not the angle that is associated with it. If we combine like terms, you guys, notice what happens with the cosines in the middle. We have a negative and a positive. They cancel out. And that will end up giving us 1 minus cosine squared A. Now that it's cosine squared, this matches up with kind of a version of one of our Pythagorean identities. If sine squared plus cosine squared equals 1, and we moved cosine squared to the other side, we would have 1 minus cosine squared on the right. That means on the left, we would end up with just sine squared. There's one term. That means we've simplified that expression completely. Let's go ahead and try the next one. Tangent A times cosine A. We have two trig terms, and our goal is to reduce this down to 1. Now, tangent is one of the examples that has multiple definitions. It's equal to 1 over cotangent, and it's also equal to sine over cosine. Well, if we picked 1 over cotangent, cotangent and cosine really don't have anything in common. But if we pick the quotient identity sine over cosine, at least we'd have cosines to work with. I'm going to convert tangent to sine of angle A divided by cosine of angle A times, I'm going to put cosine angle A over 1. Now in this product, anytime you have a matching term in the numerator and denominator, it simplifies. They cancel out. This allows us to cross off cosine A's on top and bottom, leaving us with just sine A over 1 or sine A. Again, one trig term in our final answer. For example C, this is similar to example A, where we have two sets of parentheses with addition and subtraction. What we'll need to do here is a similar process. To eliminate the parentheses, we have to FOIL. If we have cosecant angle B times itself, that would be cosecant squared B. Again, we square the trig term, but not the angle. Now, cosecant times negative cotangent, this gets to kind of be a mess, you guys, so sorry about that. A positive times a negative would be a negative, but then we have cosecant times cotangent. It's just a big term. And then to make things even crazier, when we multiply the insides, we get the same term but positive. Now we have cotangent B, cosecant B. It's a lot of letters right there. Last but not least, we have positive cotangent times negative cotangent, which is going to be minus cotangent squared B. Whoa, that's a lot of FOIL right there. So let's see what we can do. Notice that we have a negative cosecant cotangent and a positive cotangent cosecant. The trig terms are the same. One's positive, one's negative. So like in example A, these cancel out again, which is super helpful. Let's see what's left over. We start with cosecant squared B minus cotangent squared B. So cosecant squared and cotangent squared. If you look up above, I know that they're in the Pythagorean identities, but this is in a different order. The order for the Pythagorean identity is 1 plus cotangent squared equals cosecant squared. So if we have cosecant squared minus cotangent squared, it's like we moved that cotangent squared to the other side. Doing that, what we'd be left with is 1 on that left-hand side. So this time we have one term, and it's just a number. In our final example, it's always good to remember that sometimes the answer doesn't involve any work whatsoever. 1 divided by secant B. A fraction is not simplified until you can simplify it to just one plain term. We see fractions up above in our reciprocal identities and our quotient identities. But there's only one fraction that has 1 over secant of an angle. And that fraction is in the top row. 1 over secant B is going to be equal to cosine B. So sometimes it is that easy to get the answer. Everything in this row reduced down to one trig term or number. And that's going to do it for this portion of the notes.